credit or first rank goes to Dr. P.K. Ghosh, who is 83 now, who's been from the very, very beginning days. In fact, he has been with the biotech before the biotech in DBT started formally. So welcome Dr. Ghosh and Dr. Kannan and all others. So Dr. Raji Susan Mathew is a postdoc person, computer from IIC, computational and data science from IISc. She completed a PhD in the area of MR image reconstruction from IITM Kerala. Her research interests are regularization for image reconstruction, compressed sensing, deep learning for medical imaging. Now, the way things are progressing, it looks like, I don't know, maybe on a lighter side, I would say most of the doctors may lose their jobs because the machines may be doing their job. That threat is also emerging. But then with the specialization in the diagnostic process, I'm sure that professionals will still be required. They'll have to keep updating themselves to remain in the field. So let us hear from Dr. Raji Susan Mathew the challenges that India is facing with regard to this new technology and the opportunities that it affords, and how patient care is going to be improved as we go along this road. So welcome to Dr. Raji Susan Mathew. Over to you, Raji.
Thank you, Professor George, for the kind introduction. So, first of all, I would like to thank everyone for calling me for giving this talk. It is a great privilege for me to talk in front of the great people who have introduced biotech in India. So, without much delay, I'm starting. So, my talk today is on AI in medical imaging, data to deployment with insights from the Indian context. Hope the screen is visible to you. So, this is the outline of my talk.
We can see only Dr. George.
Sorry?
I said we can see only Dr. George.
Why can't you see the others?
I don't know. See, you are coming on the main screen.
Who, me?
Yeah, I can see the slides.
You have touched those, sir.
Slides,
just
right?
touch on that slide, sir. It will come into middle.
Okay. So, shall I proceed?
Yeah, you carry on.
You carry on.
So this is the outline of my talk. I will start from the medical imaging and the clinical workflow in radiology, which includes the reconstruction and image-based clinical tasks. And I will shortly explain what is the AI-based imaging workflow, and then I'll proceed to the AI in healthcare Indian scenario. So when we hear about medical imaging enables the visualization of lesions or diseases inside the human body, which enables the clinicians to come up with radiological interpretation. Essentially, they will come up with some rule out or rule in diagnosis. So if you think about the entire workflow, it typically consists of an acquisition phase wherein this data is acquired. So the patient is fed into the scanner and the data is acquired. As opposed to the computer vision task, here the data is acquired in some raw format. And finally, in the user or the application phase, we have the clinicians who are looking at the images. So they will come up with what is the problem in the images. So in between these two phases, we have this computing and analysis, wherein some algorithms are performed to obtain the clinically interpretable images. So this is the most important topic of discussion today, which is the wherein these algorithms are performed to come up with the clinically interpretable images. So what are the needs of the clinical imaging? So the important need is that we have to enable early detection of diseases or problems inside the human body, and it should be fast and it should be cheap, and the methods which we use should have lesser radiation, and it should be able to perform screening, and it should be applicable globally. So when we think about the healthcare sector, it has different types of data, right? So it has patient-generated data. When the patient shares his experiences or what are his problems to the doctors, there are a lot of data. There are laboratory results. There are patient-monitored data. So there are different types of data and the medical images are also there. But if we look at the whole chunk of data which is available, the 90% of data contributed by the medical images. That is why if at all any AI-based algorithms are going to happen or are being implemented in healthcare, it should first start with images, because we have a lot of data in the imaging sector. So this is a more bigger picture of the clinical workflow in radiology. So we can see that it starts with acquisition as I shown previously. It has a reconstruction phase wherein the image is generated. So as I mentioned previously, the data which is acquired in the medical images or to generate the medical images is not directly images. It will be in some raw format. So we have to convert this raw data to the images. So the algorithms which are performed to obtain these images from the raw data, we typically call as reconstruction algorithms or reconstruction methods. So once we obtain the images, we have to come up with the region of interest, or we have to understand what are the clinically important regions. So for this, we perform some image-based tasks which are shown here. And this includes characterization and some other tasks which are shown in the next slide. And then the clinician will prepare the reports based on these images. So once these reports are generated, then we have the diagnostics phase. So diagnostics is a much more vaster area wherein there are inputs from multiple things like a patient, what are the symptoms experienced by the patient, the blood reports, etc. And images only contribute to one part of it. So diagnostics is a much more vaster area. And we have to always remember that images will contribute only to one part of the diagnostics. So coming to the reconstruction in a little bit more detail. So if we look at this workflow, it shows a forward problem. So forward problem means the patient to be scanned is fed into the scanner and we are collecting the raw data. So here I have shown an example of MR system wherein we are interested in the brain image of the patient and the scanning is performed and the raw data is shown here. So in MR, the raw data will be typically in Fourier space. And so the problem with the MR is the longer acquisition time. So this acquiring the raw data from the object, which we call as the forward problem. And once we have this raw data, we have to get back the image from this raw data. This we typically call as inverse problem. So this requires some algorithms because typically we will not acquire all the image points which are accessible in case of MR. So we may have to introduce some additional priors or information to retrieve the image of clinical interpretation. So this is the inverse problem in MR reconstruction. So coming to the image-based tasks, so these are performed once the images are obtained. So once we get the images, we perform some task on the images to obtain a better clinically interpretable image. So these tasks we typically call as detection, characterization, and monitoring. Detection means it is identifying that there can be some potential abnormality present as shown under this detection box. And then we have the characterization phase. That means exactly delineating what is the region of interest which has these abnormal tissues, or diagnosing whether it is a benign or malignant and staging it into different predefined categories. All these things comes under characterization. And monitoring, if we look at it, so during the patient recovery time, we may have to look at the patient's images multiple times. So observing this, performing this detection and characterization multiple times at different time instance, we typically call as monitoring. So if we look at these tasks, the amount of information or the amount of time required to carry out each of these tasks increases from left to right. So complexity increases from detection to monitoring. So detection is the simplest task, whereas monitoring is more involved task because it involves detection and characterization. So these are the most important image-based tasks we consider. And so with this, I would like to move on to the AI-based imaging workflow. So when we move on to the AI-based imaging workflow, this is the typical steps which we follow to implement an AI-based imaging setup. So we start from the data, which we call as the data preparation phase. So we should have the data, and we have some models. You might have heard about different models. So model has to be developed according to the task at hand, and then we have to evaluate the model based on the some other data, and then we have to deploy the model. So this is the typical workflow in AI. So first, let us see about data preparation. So when we think about AI, data is very important. So here I have shown a graph which shows the x-axis is the amount of data and the y-axis is the performance. So here we can see that the traditional machine learning, after some typical amount of data for a particular task, we can see that after some time the performance flattens or it reaches a plateau. Whereas in the case of deep learning, it requires much more data to achieve the higher performance. So this itself implies that we require a lot of training data to achieve a performance, which is actually which we are imagining, or what we require. The high performance, what we call, we need lots of data. So here also I have shown what are the reasons for the DL success. Mostly, the most important thing is the availability of GPU. We have graphical processing unit which can handle lots of data and which can train using this data. So this complex relationship between the input and whatever output we are looking for. For example, if we are looking at the segmentation of an image, we are delineating the exact boundary which has some abnormality. Then this relationship is learned using the model which we are actually training on. So we require lots of data. That is the first important thing which I want to highlight. And secondly, why we need a data preparation. So coming to the medical imaging, data privacy is very important. So typically when we think about AI algorithms, they may not be done, these AI developers may not be in the hospital. So data is collected in the hospital and these AI algorithms we may be doing it in some other center where this AI experts are working. So they may not have direct access to the medical imaging data. So when we are transferring this data to a third party, we have to ensure that the dignity, respect, individuality, and autonomy of the patient is protected. So there, for example, when a patient is visiting a doctor, he might share all his problems with the doctor, and this he shares with whatever trust he has in the doctor. So this has to be preserved. So this is very important. That is why data preparation is typically important in the case of medical imaging, because this data privacy has to be preserved, and there are different rules or guidelines for this, including HIPAA and some other guidelines. So this data privacy is very important. So when we call that data privacy is violated, so typically when we know that wrong person gets access to this information, or the process by which the information accessed is not correct, or the process is inappropriate, or the purpose for which this access is done is inappropriate, we typically call as privacy has been violated. So this, we need to ensure that the data privacy is always being protected, typically in the case of medical data. Another important thing is that data quality. We started with the data quantity, but data quantity alone will not serve the purpose. Here I have shown a pie chart. Here we can see that the red regions, which shows the data processing time required by a machine learning scientist to do his task. So the percentage of time he allots to each of the tasks is shown in this pie diagram. So here we can see that all the red colored regions is contributed by the data processing. That means the data identification, data aggregation, data cleansing, data labeling, data augmentation, etc. totally contributes to almost 80% of the data scientist time. So this itself shows that it is very important to preserve the quality of the data. Because if we give some garbage input to the training system or the model, it may not give some good results, right? It can only give some garbage output. So the quality of the data is very important. So we have to ensure that our data which we are training has enough variability, which we are studying. It should not represent only one part of the population or something like that. It should not have biases like that. So when we are selecting the data for a particular study, we have to ensure that we are keeping all these things in mind to ensure the quality of the data. So this is the typical data preparation pipeline. So it starts from obviously the acquisition. So when we are acquiring the medical image data, in order to acquire the data, we know that we have to have some guidelines, which is by the Institute Ethics Committee has to approve our study, and we have to get the IEC approval for this. And once this approval is done, then performs the data de-identification. That means all the personal information which can identify a person from these information, for example, name, address, phone number, lots of these type of data will be there in the medical data. So these type of information has to be removed from the data. So typically we think about these type of headers or these type of identifiers like name, address, etc. But sometimes in images itself, it has been shown that from brain MR images, we can actually reconstruct the face of a person. So not only the name, any information which can identify a person from this information has to be removed. But obviously there will be a trade-off between what we can remove and what we are going to study from the data. So for example, if a person has some cancer or cancerous growth in the face, then his facial data may not be able to remove. So these type of de-identification, we have to keep all these things in mind. And also this de-identification has to be performed at the place where this data is acquired. So before transferring the data to any third party, we have to de-identify the data, and it has to be transferred after this de-identification. Then comes the curation, which actually ensures that the quality of the data is preserved. So once we obtain this high quality data, then we have the storage wherein the data is stored in different cloud or different servers within the hospital, or wherein we are going to use this data. And then we have this annotation phase. So typically when we talk about annotation or labeling in the medical imaging, it is a very tedious task. So for example, if we are looking at just the classification, the annotations can be simple, like whether the abnormality is present or what stage it is. But when we are looking at tasks like segmentation, where we need exact delineation, it is very difficult. But there are some softwares like ITK Snap and ImageJ, which people use to annotate the data. But the annotations typically take lots of time, and we always look for some ways wherein can we go for some algorithms which uses the lesser number of annotations. But getting the annotations in the medical imaging is a very difficult task, and it's a time-consuming task because the clinician has to annotate the data. So once we obtain this annotated data, then we go on to the model development. So model development typically means we have to develop different models for our task. For example, we have a classification task, we have to develop a model for that. And we have another task like segmentation. There can be some models for that task, wherein we use these type of different models based on the task at hand. So it can be like we can have the whole data. We divide the whole data into training, validation, and training subsets. And the training data will be used to train the model based on the task at hand. So we have a feature extraction pipeline wherein we extract the features in a typical machine learning setup. Like means we first extract the features and then we perform the task. But in the case of deep learning, we actually use this feature extraction, and task entire thing will be performed by the network itself. So after that, we will come up with the prediction. So this model development typically relies on the task at hand, and it can be either machine learning or deep learning based on whether we have some domain expertise or not. So we need some domain expertise to go with the machine learning domain. And if we directly give the input and we are predicting the output, we can go for the deep learning. So there are lots of models for each of these tasks. And once we have this model developed, then we have the model evaluation. So in model evaluation, what happens is that we have the model which is trained. That means we have divided the data into train, validation, and test. And we have used the training data to train the model. And once it is trained, we locally evaluate using the test data, which is our internal data itself. But for evaluation, we have to use a lot of external data and see the performance of the model on the unseen data. So maybe a model will perform very good on a local data. Maybe after testing on the other unseen data, it may not perform well. So these type of things, we have to clearly see that it performs reasonably good on the unseen data as well. So then maybe after seeing the performance, we can update the model or we can do something to improve the performance and see that it performs reasonably good on the external data as well. So finally, we have the model deployment. So when it comes to the model deployment, so typically these days we can hear about model deployment on the cloud and model deployment on the edge. So in the cloud, it is like we are sending the data to a cloud server, which is physically sitting at some other place, and we have to transfer the data. And then in the edge deployment means we will use some edge devices like mobile phone or some other devices like that. And then we use this model deployed on that. And then we are using the outputs directly from the edge server. So edge computing means, so what is the difference between this cloud computing and edge computing? So in cloud computing, we are actually taking the data, we are sending to a remote server, and then we are getting so the model will be running on the remote server and it will send results back to us. Whereas in the case of edge server, it will be, so edge computing, the main idea is that the training is, the inference will be performed on the device which is very close to the source of the data. So in this case, the main advantage is that the latency will be less. That means we need not have to send the data and we do not have to wait for the results to come. And also it will reduce the expenses. Maybe if we are using the cloud domain to save the data, we have to pay for them. The expense will be more. And also privacy concerns are there. We are sharing the data. There can be privacy and security concerns. And internet connectivity can also be a problem. But in the case of edge, if the model is reasonably a small model or a lightweight model, we can use it in the edge itself. So this also shows that for using in the edge, we have to make a model which is typically lightweight. That means if the model is very heavy, we may not be able to implement it in the edge devices like mobile phones or other Android devices or other Jetson devices, etc. So this is why we need some lightweight models. So why lightweight models? Because we need not require highly computational resources like GPUs. GPUs cost are very high and it is not something which is accessible to all. And also this devices like NVIDIA Jetson can facilitate easy training, and also the cost for these are very less. So it can enable faster inference as well, and it is deployable in any edge devices like mobile phone, Android, Raspberry Pi, etc. are these type of platforms which we can use for this as edge devices. So when we think about the lightweight CNNs or lightweight convolutional neural network, which are the typical deep learning models. So CNNs are the typical deep learning models which we consider. And so there are 4 different approaches by which we can convert a model to the lightweight CNNs. One is that we can, in the network design itself, we can do something. that means some modifications in the architecture to make it lightweight. Lightweight typically means that, so we have a model which has a typical number of parameters, and we have to reduce the number of parameters and the memory to save this model, so that we can save it on a lightweight model. So there are 4 different approaches, which is like we have to make modifications to the architecture. We can quantize the model. That means we are reducing the precision of the weights and biases which we are actually saving. So in this way, we can reduce the size of the model. Knowledge distillation means we have a large model which performs very nicely on a particular task which we are considering. But what we are doing is that we are making a small model called the student model, which actually can, which gets the knowledge from the larger model. So we transfer the model from the larger model to the smaller model, and we ensure that the smaller model can perform reasonably or almost equivalent to the larger model. So this we call as knowledge distillation. And in network pruning, what we do is that we remove some weights or layers which may not be contributing that much to the output of the model. So these type of methods we can use typically to reduce a larger model to a smaller model or a lightweight model. So once we have this, then we can deploy it on the edge. So talking about the lightweight versions, to generate lightweight versions, then we can use lightweight model development platforms like TensorFlow Lite, PyTorch Mobile, etc., which facilitates the code development and deployment on devices like Android, Raspberry Pi, NVIDIA Jetson, etc. So these are the 2 important platforms or tools which we can use, which is the TensorFlow Lite and the PyTorch Mobile. So this ensures that the latency is not there. That means the round trip to the server is now not there, and the privacy is also preserved because we are not transferring the data. The connectivity problem is not there because as opposed to the cloud computing, we need not require any internet connection to facilitate this. And also the network connections are typically power hungry. So these also we can get rid of these problems as well. So here I show some examples wherein we actually use some Android applications. So this is an example where you can see this X-ray is uploaded. So this shows an Android app which is developed, wherein we can actually upload the data from the mobile device and then it predicts on the device. So it loads the picture and then it predicts the outputs. So initially we have the model which is trained on the GPU. Then we made it a lightweight model and then we deployed it on the Android device. So this is another example which is developed in the ISE itself. So this is a COVID-19 anomaly segmentation wherein the CT scan is actually uploaded in this app, and then it predicts what is the abnormality and how much region is abnormal, and all these things are predicting. So the main advantage is that it can actually predict these anomalies within a very short time. So for example, it consists of multiple slices. So for a doctor to look at it, it takes a lot of time, but within limited time, we can get the prediction. And since it is in the mobile device, it is much more easy because we have the model implemented in the edge device itself. So there are other edge devices like NVIDIA Jetson. So these are some specifications of the NVIDIA Jetson device. So there are different NVIDIA Jetson devices like NVIDIA Nano. So these are some benchmarks for some models like ResNet 50, VGG 19, GoogleNet, and AlexNet, and what are the typical number of parameters, flops, batch size, etc. And also these are some useful links if we want to use some workstation, what will be, how to choose a good deep learning workstation. So these are some website where you can see a lot of answers to so many queries like what we have, which workstation will be good, how to use that, or whether what size is required, all these queries, we can get answers from the site. And also PyDicom. This is another tool which we can use, which is a Python package to work with the DICOM images. So DICOM files. So DICOM is the typical format wherein medical images are saved. So this is another thing which we can see. And also this is another some links which we can use for learning the deep learning with PyTorch. So having said that, I would also like to show some example of data to deployment. So this is an example of median nerve segmentation in ultrasonography. So this is an example project which we have done in collaboration with Aster CMI Hospital at Bangalore. So essentially what we are looking for is that we are looking at the ultrasound images. So here we are actually looking at the median nerve segmentation. So median nerve is a sensory nerve which is in the arm, which facilitate the coarse movement of the hand. And there is a tunnel, as you can see in the first and second images, through which this nerve passes. And when this tunnel is getting narrowed, then the median nerve get compressed, and this compression can lead to the enhancement of this nerve. That means the nerve will enlarge on both sides of the carpal tunnel, and then what happens is that it can lead to severe pain in the hand, etc. So this is very prevalent. I mean, for professionals who use keyboard and those who use musical instruments like guitar. So the most important examination is the electromyography, and ultrasonography is also used as a confirmatory exam. So also this median nerve segmentation facilitates the ultrasound guided regional anesthesia injections. So during that time also the clinician has to look at the nerve as well as the needle together. He has to manage both the things. So our aim was to, can you automatically detect the median nerve from this ultrasound images? So ultrasound images are typically difficult because as opposed to the other imaging modalities, it requires more skill to look at the images and come up with the diagnosis. So we have used this. So this is done, as I mentioned, in collaboration with Aster CMI Hospital. So we have collected around 300 patient data. So this took almost 6 months or more. And each patient, so this is a video data. So each patient has some 300 frames. So we have collected 100 patient data and there are 300 frames per patient. And what we had done is that after acquiring the data, the clinician annotated the images for us. So it was a very tedious task. It took almost 6 months, as I mentioned. And then what we did is that we used a deep learning model. Here we have used, I have shown a vision transformer model we have used, and then segmented the ultrasound frames. So as you can see here, so this is the prediction is shown in green, and the actual nerve which is annotated by the clinician is shown as red. So here we can see that when the nerve is at the top, that means at the wrist area, it is typically difficult to understand it is relatively easy to understand the nerve. But when move away from the wrist, it is relatively difficult to understand the nerve. So these are some models which we have implemented, and we have seen that this vision transformer performs well compared to the other models. But the problem with this vision transformer model was that the parameters are on the higher side, but the performance was good enough. So then we have developed a lightweight model which has relatively lesser number of parameters compared to the vision transformer model. And these are some videos which shows the evaluation on the patient data. That means, so this is not seen by the model when training. So we have used different acquisition depths, and we have obtained the videos, and we have tested it using the different scenarios. And this we actually sort of implemented in the clinic. That means we have directly fed the input from the ultrasound machine to the Laptop. So laptop was the device which we use for processing, which uses a GPU. We didn't use edge device here. So we fed the input directly from the ultrasound machine to the device, that is the laptop, using a frame grabber device. So which can be, I hope you can see it here. It's a green color device, and you can see in the picture that this laptop, you can see that this annotation is properly seen. So it has this red annotation over this median nerve. So this we have implemented, and still now also this doctor is looking at this model, how it is performing on the unseen data. So whenever new cases are coming, how it is performing, this evaluation is still now happening in the hospital. So this is the setup which we have implemented at Aster CMI hospital. So having said that, there are a lot of things to improve. Like we cannot say that it's real time. Although we say that it's sort of real time, there are a lot of things to improve. So this is sort of an initial attempt to see how we can do it from data to deployment. And coming to the Indian scenario, so there are a lot of attempts by the government of India to initiate and carry forward the AI in healthcare. So recently there are SAHI and both, which is the strategy for AI in healthcare for India, and also the benchmarking open data platform for health AI, which was announced very recently last week. So also, what are the advantages of incorporating AI in healthcare in India is that India has shortage of human resources compared to the patients incoming, particularly in rural and distant areas. So, and also the instances of cancer reported each year is rising. So this also is alarming as compared to the number of skilled oncopathologists. So these things actually highlight there are a lot of benefits which we can get by actually properly implementing AI in the healthcare sector. So these are some attempts which are made by the made in India towards this. For example, the Central TB division under the Ministry of Health and Family Welfare has this MOU with Wadhwani Institute of Artificial Intelligence for deploying AI-based solutions for tuberculosis. So some other examples like Madhu Netra AI and also Cuff Against TB. So these are recent advancements in AI-based healthcare in India. So also we have seen this COVID-19 crisis in India. So during that time, we have started using, and so it has been shown that India saw a very high rise in the use of AI during that time. So this has been reported by PricewaterhouseCoopers. So also we have to highlight the fact that during the COVID-19 time, the proper tracking, so whether the coronavirus is contained or traced, the quarantines, all these things are facilitated with the use of different AI-based tools as well. So having said that, there are different, so data set is an important thing which we need when we have to develop AI-based methods. So there are Indian medical data sets available. Some examples I have shown here. For example, this Indian brain segmentation data set by Shivaswamy et al. This is one of the important data set which consists of the brain MR data sets. And also this Indian diabetic retinopathy image dataset is a well-known dataset which is used by lots of scientists to conduct their AI studies as well. So these type of medical datasets, as well as this DBT National Brain Research Center has introduced this Swadesh project, which also is a brain initiative which provides certified neuroimaging, neurochemical and neurophysiological data. So this is also another attempt towards the development of Indian medical dataset. So the most recently we have this project IDAS, which is a ICMR and ISC together is developing a center for health data. So this is still in progress. So they are collecting the data from multiple modalities as well as multiple centers, and still in progress. So these attempts are actually very good, as as we can see that we have to implement some AI-based method for India. We need medical data sets in India. So there are lot of attempts towards the medical data sets in India these days. And we can see that we can use these type of data to develop AI-based tasks as well. So having said that, there are some challenges which we need to know that. So the most important challenge, there are available, absence of high quality data sets in different areas. We consider, for example, if we consider HIV studies or some studies related to some typical cancers, etc., we have only some limited data sets in some areas of study, but we have to get lots of high quality data sets, and also the cultural biases in data sets. For example, we know that sometimes in our health records itself, it's handwritten. Some of the health records can be handwritten, and also the regional, it can be written in regional languages. So these are some challenges we have to face while implementing the AI-based healthcare in India. And also, whenever this data is available, whether these are publicly available, so this is also another concern which we have to have while implementing this. And also the lack of suitable infrastructure. So we have a lot of attempts towards all this. That means we are attempting towards how we can remove or how we can mitigate these challenges, but still we have lack of suitable infrastructure. For example, if we have to train the models, we need lots of GPUs, but there are a lot of attempts to generate or make the GPU available to the students and all, but still we have lot of lack in the infrastructure as well. So again, lack of professionals who are well aware of this training, how to use this AI-based technique, that is another important challenge which we have to mitigate. Another important thing is the initial investment. As I mentioned, we need lots of GPUs or compute for making this AI in healthcare practical. So that is also one important challenge which we are facing. Another very important challenge is acceptability of the outcomes produced by the AI algorithms. So we have talked about AI, it is predicting, it is giving this much good accuracy, all these things, but whether we are actually able to convince the doctors or convince the patients that, okay, these results are reliable, or how this output is actually being produced. So the trust and the acceptability of the outcome. So we may have to develop some algorithms which we can explain how the output is produced, what the machine is looking at to produce this output. So this has to be improved, and this is one important challenge. And also lack of knowledge of the AI among the general public is another important challenge. So generalizability is another challenge. Generalizability means, for example, as I mentioned, we have lots of data. For example, if we are training the deep learning model using only some data or some skewed data which represents only one sector of the people, so these can lead to false findings, and it may not work well on the general data when we consider. So we have to ensure that whatever model we are developing we have to check the performance, or we have to evaluate the model on some standard data sets, and we have to come up with strategies which can show that this algorithm really performs well, not on a skewed data, not on some subsection of the data. So generalizability means actually we have to perform, an algorithm has to perform equally well on the unseen data. That means during the training we have seen some data, but it has to perform well on some data which is not seen during the training. So this has to be ensured. Another important challenge everybody is facing is the privacy problem itself. So we have to ensure that the privacy of the patients are preserved. So cybersecurity is another important significant problem. So what can be the potential solutions? So coming to that, so one of the important thing we can do is the collaboration between the AI experts and the domain specialists. Of course, the domain specialists are doctors. So we have to have collaborations, and we have to discuss how these things has to be, these challenges can be overcome, and also we have to train the people to use the AI, how to use the AI, and what are the laws. So enforce the laws, and we have the laws, but whether we are actually enforcing the laws, whether everybody is abiding by the laws, whether the privacy is preserved. So these type of things we have to ensure, we have to enforce these things, we have to make sure that these things are being being followed by everyone. That is another one important thing. And also we have to ensure that we have some benchmark things which on which we show the results, and not it's not like we are always been showing the results or showing just for the sake of some method. We are developing some method, we have to ensure that it is justifiable and explainable as well. So what are the things to remember? So we have to always remember that AI, it's a very expanding and very booming area, but we have to ensure that it is being used for the good of the society. We are being following the ethics of the AI. So, and also we have to ensure that we have to note the fact that the findings are not always generalizable across clinical settings. So we may not overestimate the efficacy of the algorithms. And also we should always perform the studies on standardized designs, and we have to ensure that we are showing it on some benchmark data sets. And also with the digitization of the hospitals, wherein all the data is entered in digitized format, we can hope to see that AI tools will be emerging very soon. It's already been used in some part of the healthcare, but it will be used in much more ethical and good way. So with this, I would like to conclude. These are some acknowledgements. So once again, I would like to thank the organizers for giving me this opportunity. So if you have any questions, I'm ready for questions.
Thank you. Thank you, Dr. Raji, for the presentation. I'm sure there will be some questions, so I leave the presentation open for questions.
Can I just, I'm
Yes.
Jagannathan from Hyderabad.
Okay.
Yeah. So, madam, it's a wonderful talk. And you have opened up a new area, particularly in the clinical, this one in India, but definitely that is so. So, what the image that you have developed for the ultrasonography, the pointer that you are showing red and that blue color, when you generate, when you with a clinical expert interpretation and then compare with the AI interpretation, where are the advantages that have emerged? You know, is it time? Did we reduce the time of detection, or did we increase the precision in that particular one? This is one question. And my second question is, generally, for example, now you are telling how to extend it to the other areas and make people to, accept these kinds of data. A very simple thing what comes to my mind is, see, we have been using epidemiological data, particularly for diabetes and blood, this BP, the data that is generated mostly by European laboratories in the European population or Western population. And based on that, we are prescribing medicine in India. Of course, now recently some epidemiological studies have started, but epidemiological studies also have the problem of these devices and collecting the data. This is what people have so far mentioning. Now with the application of AI, for example, with a mobile, as you said, some of the devices you can get the data. If you can get the data of the normal individuals in various genetic population across India, for example, somebody staying in Leh Ladakh or somebody is staying in Kanyakumari, they will have different genetic pool and different, data for their blood pressure and sugar. So can we generate this epidemiological data using these tools? This is my second question, because we have a huge genetic diversity and also way to generate data. The problems now we can overcome with AI. These are the two questions.
Thank you. So for the first question, so the most important advantage when we use this AI for this ultrasound one is that typically doctor has to annotate this median nerve and look at the cross section. So it requires some time for the clinician to annotate the data. So this time can be reduced with the help of this AI. But the problem with this is that may not be in some cases where the cross-sectional area is large, it will give it has shown to give good results. But in some bridge brim areas, like for example, it is just developing this cross-sectional area enlargement. So there is a chance that we can miss that also. So that is still under study only. The advantage is that we can reduce the time the clinician is spending for this annotation to look at the cross-sectional area. For
Can
the
I-
second,
Can I request, there is a lot of echoing. So those somebody who's not speaking may kindly switch make it mute, Mute yourself, unmute yourself when you want to speak. Thank you. Thank you.
so regarding the second question, epidemiology data. So for example, there are a lot of attempts in India to develop indigenous data sets. So I hope that this type of data can be developed in India and we can develop AI algorithms to do the study which are of interest to us.
In fact, Dr. Somnath Karmakar is there, who has been from the public health. So you would like to share some of your experience. Dr. Somnath.
Thank you, sir, for the invite. And I must congratulate the speaker for a. Am I audible, first of all?
Yeah, you are audible. Yeah.
Okay. So I must congratulate the speaker, madam, for a very excellent talk. And, once you attend such a webinar, you learn so many things. So it sounds very interesting. You were able to generate a report within a very reasonable, within a very short span of time. So, and it is mostly accurate, you see. And madam has already said about the predictability, generalizability, and all those things. So, but there are certain concerns. Can we go wrong somewhere? I think the question was also addressed to that. The question that was asked by the previous participant, that when there is so much of data variability genetically and anthropologically and geographically, how do we generalize it based on the available evidence, based on the available findings, the data? So that is a concern, and I believe this is the programming part wherein they will definitely, madam will answer, of course, this question again. And it should be taken care of by the programming aspect, by the experts who will be developing this program. They will keep on modifying this AI model, I suppose. Secondly, these AI, which I understand, I believe they will be accurate up to a certain extent, as a general principle. But there will be individual cases wherein, they are to be interpreted according to the clinical experience, according to the particular, perspective of that particular case, clinically and presentation wise. So those will be the challenges. So I think madam can throw some more light on this. Thank you.
Yeah, thank you, sir. So whatever sir has mentioned is very important. Actually, when we are developing the model, we always wrongly use the word diagnosis. So we cannot tell that we can use directly for diagnosis. We can say that we can use it for a screening tool to be on the safer side. And also we have to ensure that. So for example, if there is a person who has a cancer and it is not being detected, it is a problem, right? But if it's a problem, if the person is not having cancer, but our algorithm is telling that he's having cancer, he will go to the doctor and see that he is not having cancer. So we have to ensure that this is a problem with the algorithms, and it's still in the developing phase only. But we have to ensure that these type of false negatives are being reduced. So false positive is fine, then he can go to the doctor and see that he is not having the disease, but false negative has to be reduced for any algorithm. And also, we cannot say that it's a diagnosis. We have to use these models as we have used this model as a screening tool, and mostly people say that they use as a screening tool. But towards diagnosis, I feel that there's a lot more way to go. I hope this answers the query.
Yeah, I think you have made a very valid point that it is more for screening. And once you have a doubt, you can, the doctor can consult and, rule out yes or no. I think I totally agree. It is not a diagnostic method yet, but it's a screening method to rule out many possibilities. So out of 100, say you might remove 95 so that you can only focus on 5. Am I right?
Yes.
Yeah. George, you are muted, I think.
Dr. Ghosh, you are not audible. Dr. Ghosh, you are not audible. Can't hear you.
I think that Somnath wants to talk. Ghosh has left, I
Yeah.
think.
Yeah. Dr. Somnath, you want to talk? Yeah.
Yeah, I think he wants.
I want to ask one question to madam, I mean, which I feel is an issue, is a concern. Like you have to, when you develop these algorithms, you basically, quantitate the data, bring it into smaller bits. So how small you can, divide these data into so that your final product is accurate. I don't know whether I have been able to ask the question properly. What I am trying to say, if you quantitated data in millimeters or in centimeters or in miles, your accuracy, matters. So, how do you do that? Because it is such a huge data. It will be a special data and what type of data, all types of data. How do you quantitate it and integrate it finally? That is my question. Thank you.
So this data, I didn't understand the question properly. That means the data which we have used is the imaging data only. That is what you meant, right?
Yeah. Image is there, but how do you see the image? What is the resolution of the image? That matters. You see, if you resolve it to a very great extent, so the image quality will be better. But if you resolve it at a crude level, say at 1 centimeter level,
Okay.
so the data will be interpreted accordingly. If you resolve it at a millimeter level or at a 1 kilometer level, that is my question.
That is true. That is true. But here we have not done such type of varying studies. We have not done. We have done only for that resolution which the doctor looks at.
Hello.
Yes. Yes,
Am
doctor.
you can hear me, no?
Yes.
Yes.
Yeah, okay. So let me say that, Dr. Raji Susan Mathew, who is a young scientist, made an excellent presentation on how AI-based healthcare shall make significant contribution to our life. She spoke specifically for diagnosis and treatment. And I think, in my imagination, that this AI will be combined with the machine manufacturers who are making CT scan machine or MRI machine or let us say ultrasound machine or other machines, and then these machines will be hooked up with the AI algorithms so that you are in a position to uh, take information on people who are living, let us say, in a remote village. So there is no doctor, but there are machines. So in those cases, it would be very easy to get a diagnosis of what is happening to that person by if there is a CT scan, MRI or other machines, and if there is a hooking up with the AI related algorithms. So this will enable detection and monitoring of diseases. This is what I could understand. Dr. Raji may like to say whether I am right or not. One thing, but this diagnosis and treatment of diseases like cancer, what she said, or those kinds of diseases which are very life-threatening, requires the patient to be admitted to some hospital. Otherwise, merely by detecting, it will not be enough. So first thing is of course detection, because without detection, how can you make a further move? So that way I find that if we develop very good AI system hooked up with the machine manufacturing people, then in the remote villages also, if there are rich people, because there is a lot of rich people stay in the villages also, because they have lot of land and other properties. So if the diagnosis is made properly, then they can very quickly move to the hospitals, and then treatment can be made. There also monitoring can be done. So what Dr. Raji had said specifically is actually regarding diagnosis. She had written a very good uh, article on a book that I am showing just here. This book has been edited by Dr. George John and our friend, another one friend. Uh, I have also a chapter there. Now, whatever Dr. Raji has said, this indicated, this gave me an impression, because I am specifically a person who deals with, who has some knowledge of regulation. Now, since I am getting an idea that lot of personal data will be available in by this system, there has to be regulation which does not exist today. There is no law actually. For example, Environment Protection Act, we had laws. We can implement that law and even arrest the person if there is a misuse. But here, India being a country at the present stage, it will be very difficult to keep such data secret. So I would like to just, of course, this question Dr. Raje cannot answer, but yet I'm just telling you this is basically a regulation type of question. But this issue is going to become a very important point in AI usage. In addition to this, my detailed knowledge is that AI is not used only in diagnosis, monitoring, and treatment. It is also used for discovery. Now, on this, India also has made a lot of promises in the parliament that lot of money is going to be spent for developing recombinant DNA products, new technology products. So there also AI will be used in discovery, I'm talking of. What is your opinion, Dr. Raje, on these aspects, discovery of drugs? Thank you.
Thank you, sir. So, as you mentioned, this if for the diagnosis, the companies which develop these machines, like for example, ultrasound machines, GE is also has implemented several. They are also in the study phase. I think they have also implemented in the machine several AI algorithms which can use these tasks. So, as you mentioned, the finally the companies has to use these algorithms and to come up with screening tools. So having said that, coming to the last question. So in the drug discovery, as you mentioned, it is being used and it is used. It's a very booming area of research as well. But I'm not sure about the developments in that field, but I know that this can be used for drug discovery as well.
No, I am just mentioning this about regulation because
Yes, I
I find in the internet there are plenty of fake deep AI based programs which government is not trying to stop. Now, if these kinds of things happen, then my personal data, which will be used by a medical person, will go to the public domain. So I am afraid of that. That is why I mentioned about the regulation part.
that is true. Regulation is very important.
Okay, thank you.
Yeah, but yesterday I was listening to Sarvam AI, where they have been able to integrate a lot of Indian languages for translating, the data and things like that. I think we expect, I think another few years, we'll see a lot of new ways to look at the whole thing. But but how are you motivating students to get interested in this? Because a lot of courses will start. So what do you think is the basic ingredient to become an AI specialist?
So in the ISET, the program started recently, 2020. So initial batch, I think it was little bit difficult to get students for AI, but the recent batch, students are very interested to take AI, and even the last student, I think the CGPA is close to 8. So students having this great boom of AI and data science, students are very much interested to see what is happening with AI, specifically computer vision, other automations, robotics, these type of areas. They are also interested to see how they can use this AI to for those areas. So now it's in a, I think it's very easy to get students. I don't know after some years what will be the situation.
I think it's an important development, and you rightly said that it needs the confidence of the people, using it. All these initial technologies perhaps can take time to standardize. So we can think of strengthening these, we can adhere to these questions raised by Dr. Ghosh and other, look at the personal data and all those things. Then these can be incorporated that, and we have to infuse confidence in the students. We have to infuse confidence into the healthcare scientists or whosoever is doing that. It's a good development. We should concentrate. I'm sure government is providing, a lot of support in that. We should try to get some more support and some, help to you for, getting other people's also some fellowships or like that. It can be developed further, because all these new developments would take some time to standardize. Thanks.
Thank you,
I have
sir.
a question. I have a question which is more trying to balance the promise and the problem. I just want to know how much of a hype is there in AI, because this has happened with everything that has come up new. And how much of a hype is there? And what are the chances of our losing track of it by rushing headlong into it?
Yeah, that is very true. So, for example, if the student, if we tell also, they are more interested to see how much it performs. So they are not worried about what is the data. So how much we have to benchmark against the standardized data sets or something. So that is true. There is a too much of overemphasis of results or something because they just want to show that it performs better than the existing methods. So whether that is true in a general sense, that is not ensured in all these cases. So that is obviously there. So for this, we have to ensure that it has this generalizability studies and it performs with a standardized design. Study is done with standard design.
Thank you. Thank you.
Thank you, sir.
In fact, these are prediction technologies. You gather data, develop software for that, and predict.
One more thing is everybody used to say that you need a lot of data for machine learning. Now, what happens is that a lot of data is not always available. I'm speaking from personal experience also. Is it possible that your tools will become sharper so that you can interpret based on limited amount of data? For instance, in in human genetics, when you're looking at population studies, you can't get data that is not available. You'll have to go by the data that is available, and they may not be available in the way you want it. It's not a planned experiment. So when this we have seen in statistical limitations, you identify a tool which can operate in a limited manner. For instance, human genetics, you're not conducting experiments. You have to go by the data that is available in the population. Similarly, there would be data which is not to the satisfaction of the person who's performing the test. Do you anticipate fine-tuning of the tools so that with very limited data also interpretations can be made? Now, if you go to a doctor, he looks at you, the old doctor, he palpitates and then he comes with the diagnosis. He doesn't look at 100 patients. His experience is based on hundreds of patients. But he does it on a case-to-case basis, he's able to do. So is there some possibility of the amount of data requirement getting reduced as the AI tools become final?
What you told is true. There are attempts towards the development of algorithms which can work on limited data. So limited data studies is an important area of research. And also there are attempts to develop some synthetic data based on the existing data to increase the actual data which we are having. So these two branches of studies are there in line with this topic.
Using limited data may lead to more of erroneous results. The bigger the data, I think you get more the confidence.
Correct. What you told is true, but there are attempts to develop algorithms which can come up with good results from the limited data. But of course, when the data increases, the performance quality increases.
Mm-hmm. It's a good development. I think one can continue with the whatever possibilities are there to prove it.
Thank you, sir.
Yep.
Any other questions?
Good.
So what's the consensus? Shall we conclude?
Yeah,
Yeah.
Doctor.
Thank you. Yeah, I think Susan, Raji Susan, thank you for sharing your expertise. Nice to hear you.
Thank you, sir.
I would request you to be part of the SBPI.
Sure, sir.
Probably be connected with it and probably invite a few of your friends also to join the Society of Biotechnology Promoters of India. And if there are opportunities, we would like to collaborate with you in organizing more webinars. Let's say if you are organizing something, you want SBPI to participate, you can do that, because not all our members have joined today. But you have a very rich expertise that is available with SBPI and KK Biotech. So consider the possibility of having joint programs. and do consider the possibility of joining. There's no compulsion. I'm just saying this as a off-the-cuff remark. But I personally enjoyed your talk, and I'm happy that it is coinciding when the AI summit is going on. So it couldn't have been a better time for this. Thank you for sparing time. Thank you for spending time in preparing this slide. It's been a very, very interesting talk. Thank you so much on behalf of all of us. We would wish you a very successful career, because you are a very, a beginner. So we would like to see you go far and develop international collaborations and see that you grow in. You are now in ISET. You are now in ISET. It's a good template for you. Wish you a lot of success. Thank you so much.
Thank you very much.
Thank you, and good night to all the
Thank
participants.
And I
Thank
would say that maybe you can approach any one of us in SBI. We can support you in all your, making connections and all those things.
Thank you, sir. Thank you very much.
Whatever support we need. Okay, thank you.
Thank you
Thank
very
you.
much.
Right.